Attention everyone, we are shortly beginning the next session. I request Sri P. Jayasimha, Project Director Sir, to kindly deliver his talk on today's theme.
Hello. Am I audible?
Yes.
Friends, there are still some seats in the front row. We have to go all the way back. My friends in the back row, can you come forward? Ajay. Shall we start? Whether the screen is visible? Sorry, it is a bit small screen. Therefore, I am asking friends sitting on the back row can come forward. There are a few chairs here. Okay, let us begin. Today's topic is Aryabhatta to Gaganyaan, Ancient Wisdom to Infinite Possibilities. Aryabhatta is the first spacecraft made by ISRO, and Gaganyaan is our future spacecraft which is being done in ISRO. To start with, let us look at the person Aryabhatta, our ancient scientist, who was in 5th century. He was a mathematician, he was an astronomer, contributed a lot to mathematics and science. Here is the list of his contributions. It is difficult for you to read, but all that we know is the decimal system, which starts with 0, is the contribution of Aryabhatta. Pi, which we use in mathematics, is invented by him. If you look at a few major contributions related to astronomy, Aryabhatta correctly insisted that the earth rotates about its axis daily, and that the apparent movement of the stars is a relative motion. When the European world was in a confusion whether Earth is the center of the universe or Sun is the center of the universe, Aryabhatta described a geocentric model of the solar system, and he said Sun is the center. Those who have studied science will be knowing that it is in 14th century European scientists discovered that Sun is the center, but we found it in 5th century itself. Solar and lunar eclipses he has explained, which is quite accurate even with today's technology. That is the kind of knowledge our ancestors had those days. If you look at the list of scientists of that era, The list goes like Lagadha, Aryabhata, Brahmaputra, Varamihira, Bhaskara, 1 and 2, Lalla, Shripati, Mahendra Suri, Gautama Siddha, and so on. There was a discussion in European community whether the earth is round or flat. For a long time they used to believe that earth is flat because it looks flat. If you go outside and see, will it look round or flat? So European scientists told earth is flat. But what we were thinking, you are all studying in English medium, right? What is the Hindi version of geography? Correct? Bhugol. What is meant by goal? Sphere, round. So we were told on that day itself it is goal, it is not flat. Correct? And we called the space as Khagol. We were very clear, no confusion. That was the level of knowledge we had. Not only at that time, even the later. If you look at the scientists, starting from Jagadish Chandra Bose up to Abdul Kalam, we have plenty of scientists from this land who have contributed to science and technology. And remembering them, paying honor to them, let us spend some 45 minutes to look at how India has grown in space technology. When you think of space technology, we have to remember this great thinker, Vikram Sarabhai, son of a big industrialist from Gujarat. His father had around 7 to 8 big factories in those days. Normally, a father of such stature, what he expects his son to do, take care of his industries, right? So same thing his father told. But Vikram Sarabhai was interested in physics. He wanted to do research work in science. Father wanted him to work for factory. So there was a controversy. Father wants him to work in factory. Vikram Sarabhai wants to work in science. When there is such confusion, normally in our house what do we do? Vikram Sarabhai went to his mother. See, father is telling like this, but I want to do. Normally we will go to mother for settlement, right? So he also went, then mother told, you do one thing. Let Vikram take care of 3 industries. And let him continue his science study also. So, balanced solution. Then he started working in space science. And he was started launching small rockets. And he selected his working place at the south tip of India, near Thiruvananthapuram. He started launching rockets. Why Thiruvananthapuram? He is in Gujarat. Why he went to Thiruvananthapuram? It is because of this. The place is called Tumba. Tumba Equatorial Launch Station. They used to find this stuff, launch this type of small rockets. The reason going for Tumba is that, you see, this central line is called equator. We have all studied about equator in science, correct? This is the geometrical equator. But you see one solid line going here. This is called magnetic equator. There are 2 equators for Earth. One is the one which is marked on the globe. Other, there is a magnetic equator. Earth is a magnet. And there are places where the forces of North Pole and South Pole will be equal. And that is called as magnetic equator. And you see that magnetic equator passes through the south tip of India. Can you see? Otherwise you see the bigger image. This is the geomagnetic equator. It passes through here and it passes through Tumba. He wanted that place because the magnetic disturbance will be zero. And when he found that place, not only Indian scientists, the whole world scientists said, oh, we have an excellent place to do research. What did they do? They said, anyway, Vikram Sarabhai, you have good place, we have good rockets. And we were searching where to launch. And you are searching what to launch. We have rocket, you have place, we will give your rocket, you launch in your place. See what a good collaboration. Otherwise you have to go and request Russia and America, can you please give your rocket? Now we have an excellent place. This is businessman tactics. So he got the rockets from them and we started launching here, did lot of scientific research. There is one interesting story. There was an Apache rocket given by America, NASA, and that they wanted to launch in Tumba. It was a very famous launch event planned. Scientists from America, scientists from Russia, scientists from Europe, all had come to Thiruvananthapuram to see that launch. The government of India felt it is an important event. Therefore, they gave all required facilities to the scientists team, and Prime Minister told, I will also come. Now you see, this is an important launch. All scientists are there, and Prime Minister also is coming. That was a small rocket, and the tip of the rocket there will be one chemical, ammonia chemical, which is dangerous to human beings. Therefore, scientists thought that let us assemble this tip 4 kilometers away from the launch pad. On the launching day, where launch happens in the evening 4:30, morning you keep it ready. They told two scientists, you take care, you be in your place, 11 o'clock a jeep will come, you bring that rocket tip cone to the launch pad, assemble, evening we will launch. Plan is good. These two guys were waiting. 11, 12, 1, 2, gaadi nahi aaya. Now see, it is becoming 2 o'clock. Launch is by 4:30. If this tip doesn't go there, no launch. Is it not? Because part of the rocket is sitting here. What to do? They looked for one. Outside when they came, they saw one fisherman's house. In front of fisherman's house, one cycle was there. Then they thought, okay, you take this cycle, let us put a rocket on the cycle and move. And sorry, before that let me complete. This is the payload that they are assembling. It is seashore. Seashore will not be like Tawang. It is quite cool. Seashore will be very hot. And that too, summer, it will be worse. And you see this great scientist has removed his shirt and working. And this fellow is supporting him. And this person is called Dr. Aravamudan, a great radio scientist who invented many instruments to communicate with rocket and satellites. Later he became center director for our own center. And the person who is helping him, yes, APJ Abdul Kalam. This is how people used to work. Normally when we think of ISRO or very big sites, we think people will be very posh, with court, with all facilities. No, it started like this. And this is the story I was telling. They are carrying the tip of the rocket on the cycle. And the person who is working here was Mr. C.R. Satya, who is instrumental in bringing new technologies to ISRO. And this is how the journey started. Any journey, the start will be like this. Today we have an excellent launch pad in Sriharikota. But when we started, it was a barren island, nothing was there. People started working, they developed. And that is how today ISRO has achieved. He is Professor U.R. Rao, who is instrumental in making satellites in India. He is considered as pioneer of Indian spacecraft technology. He was working in the same Thiruvananthapuram. Vikram Sarabhai one day called him and asked, see, Rao, you have to prepare a project report of making spacecraft in India. In 3 days he prepared the project report and he gave it to him. Sir, I have written everything. What resources are required, what technology is required, what satellites we have to make, everything is written. Only thing that you have to decide is who has to lead this team. If you decide that the report will be ready, we can start. Vikram Sarabhai told, where is doubt in that? You only have to do that. That is how the work was given to U.R. Rao. Then he took up and he started making satellite in India. And if you look at the space technology, there are 3 segments in space technology. One is spacecraft, which we make and send it to the space. And to carry the spacecraft, we want a launch vehicle. There are a few rocket models here. And the one satellite model is also kept here. This rocket is used to launch this spacecraft to the space. The spacecraft will be kept at the tip of the rocket. You might have seen the live telecast when the rocket launch happens. Stage by stage it will fall and finally spacecraft will be injected into the orbit. And when all this is happening from ground, we have to command and control. Therefore we need ground station. Spacecraft, rocket, ground station put together is space technology. There are organizations in the world who are very good in making spacecraft. You might have heard of SpaceX. They make rockets. Ariane Space, they make rockets. Similarly, there are organizations who will make only spacecraft. ISRO is one such organization who are contributing in spacecraft, rocket and ground station. All we have, end to end. Now if you look at spacecraft, there are 3 types of spacecraft based on application. One is communication spacecraft, which is useful for our mobile communication, TV live, news telecasting. The other is remote sensing spacecraft, which will take photographs of the earth in different frequencies for different applications. And third are special missions. INSAT and GSAT series of India will come under communication spacecraft. Whereas RISAT, OceanSat, Cartosat, AstroSat kind of names, those spacecraft will come under remote sensing. Chandrayaan, Mars orbiter mission, Gaganyaan, these spacecraft will come under special missions. These are the major 3 types of spacecraft that we are making in India. Depending on the spacecraft, we have orbits. Orbit is the path in which the spacecraft will move. All communication spacecraft will go in geostationary orbit. In geostationary orbit, the orbit will be in the equatorial plane, geo-equatorial plane. And it takes spacecraft to go around Earth in 24 hours. spacecraft will go around the Earth in 24 hours. How much time Earth takes to go around itself? Earth is also rotating, right? For one rotation, how much time it takes? That also 24 hours. Earth is rotating such that it takes 24 hours for one round. Spacecraft also takes 24 hours in one round. That means, I am the Earth, there is one spacecraft in front of me, I will turn 10 degrees, spacecraft also moves 10 degrees. I will turn 45 degrees, spacecraft also moves 45 degrees. As I rotate, spacecraft also moves, correct? For me, it looks as if spacecraft is not moving because it is always in front of me. Spacecraft looks stationary, standing, with respect to Earth. In Greek language, Earth is called as geo. That is why you have geography, geology, it is related to geo-Earth. Since with respect to Earth it is stationary, it is called as geostationary. All communication spacecrafts will be in this orbit. Whereas remote sensing spacecrafts will move from pole to pole. North pole to south pole to north pole. Since they move from pole to pole, they are called polar orbits. Scientific orbits, special orbits, it will be designed based on their application. There is no fixed orbit for that. Depending on the application, those orbits are made. So, based on the spacecraft application, we have three types of orbits: geostationary orbit, polar orbit, and special orbits. With this background, let us look at the spacecraft and launch vehicles that we have made till now. The first spacecraft was made by Aryabhatta in 1975. Nothing was known to us in making spacecraft. U.R. Rao and his team started working. 3 years they completed one spacecraft. Russians were launching, they were developed a rocket. They were looking for a spacecraft. And we want making spacecraft, we were looking for rocket. Again, win-win situation. We will give satellite, you give rocket, launch. Like that, this was launched from Russian rocket. We continued with Bhaskara 1, Bhaskara 2. These are all experimental satellites because we had no idea how to make satellite. Initially, we have launched to see whether we are capable of making the satellite and working with the satellite. With this, we learned how to make satellite. And we continued with Stretched Rohini Satellite Series, SROS. This Stretched Rohini Satellite Series, we were able to launch in our own launch vehicle, Augmented Satellite Launch Vehicle, ASLV. After the lecture, if you come close to the stage, there are 3 rockets here. The one at the center is Augmented Satellite Launch Vehicle. These were all very small satellites. We were able to launch in this. We continued with remote sensing satellite IRS. We made IRS 1A, IRS 1B. But these are a bit heavier satellites. It cannot be launched in the ASLV. We got launched from outside. At the same time, we thought of developing our own rocket for launching this type of spacecraft. So we developed a PSLV, Polar Satellite Launch Vehicle. It is called polar because it is meant for taking spacecrafts to polar orbit. Different IRS programs like IRS-P2, ResourceSat, AutoSat, RISat, OceanSat, this type of spacecraft as heavy as 1500 kg we started making. Generally we will have a question, how big will be a satellite and how heavy will be a satellite. The first satellite Aryabhatta was 350 kg. Whereas these IRS spacecrafts will be around 1500 kg. We need a crane to lift the spacecraft. Such a spacecraft can be taken to polar orbit in this rocket, Polar Satellite Launch Vehicle. We wanted to have communication spacecraft. But suddenly if you go and ask the government, we want communication spacecraft, you give a few 100 crores. Any government will have a doubt whether this technology will really work or not. For that we did one small experiment, satellite instructional telecommunication experiment. We took a big antenna and TV set to different villages of the country. And we placed those antennas. And from central station we telecasted the TV signal to these antennas and all villages started watching TV live. And they said, yes, this is really working. It is not that to see a movie we have to go to theatre, we can see in the TV, in any place in the country. If Prime Minister gives the address, all Indians can see at a time. When government agreed, they cleared to make communication spacecraft, so we started making first communication spacecraft, Apple. Here also you see how beautifully we did the management. Arianespace was a new company which was coming up in Europe. They were making a rocket, Ariane rocket. Any first rocket, people will have doubt whether it will fly or not. So nobody wants to give satellite to such a rocket. New one. There is a famous joke. One patient was on the operation bed and he was very fearsome, nervous. Doctor asked him, "क्यों इतना घबराते हो?" नहीं सर, ये मेरा पहला ऑपरेशन है. घबराओ मत, मुझे भी ये पहला ऑपरेशन है. Doctor also is doing for the first time. Like this, he is making first rocket. Who will give satellite for that? We are making first communication spacecraft. Where I can get money for that? We don't know whether my spacecraft really works or not. So Ariane told, if you are ready to give your satellite, we will launch for free of cost. Good. It is Ariane Payload Passenger Experiment, Apple, not our Apple. It is the abbreviation of Ariane Payload Passenger Launch Experiment. So they launched. It had some difficulties, but we got confidence that we can make communication spacecrafts. We continued. We made INSAT 1 series and INSAT 2 series. INSAT 1 series, 4 satellites we did along with American agency. And by the time we learned how to make communication spacecraft. All INSAT 2 series we did by ourselves, but launched in Ariane because we were not having such a big rocket. Reason, the remote sensing satellite weight is 1500 kg, whereas this satellite weight will be around 2200 kg. PSLV cannot carry 2200 kg. Therefore, we went to Ariane and we launched in their rocket. Subsequently, we made our own rocket, GSLV. GSLV is Geostationary Rocket Satellite Launch Vehicle. We saw one geostationary orbit. It can take 2300 kg spacecraft to geostationary orbit. The big rocket model which is in that end of the stage is GSLV. We made GSLV and started launching our own spacecraft. And later we made a series of communication spacecrafts under GSAT, where we have now around 13 to 14 communication spacecraft working in the space, working for India. And GSAT 11 is one important communication spacecraft that I want to mention here. Till now, this is the heaviest spacecraft we have made. 5854 kg, close to 6000 kg. We started our journey with 350 kg. we have grown 20 times. This is the biggest and most powerful communication spacecraft we have made till today. That is the journey. Scientific spacecrafts also we started making to help science community. Re-entry experiment is one important experiment we did. Once Professor URSC was addressing media. One press person asked, "Sir, is it possible for ISRO to take man to moon?" He said, "Why moon? We can take to Mars also. Challenge is to bring back. वापस आना मुश्किल है." You all have seen, we have lost two Indian origin scientists and both of them lost their life while coming back. Going is very easy. So for return experiment, we made one science experiment and we are successful. We made astrosat to look at the stars, study the stars. Chandrayaan-5, Chandrayaan-2 and Chandrayaan-3 are now very famous. Mars orbiter mission, which people called Mangalyaan. ISRO never called it as Mangalyaan. For us it is Mars orbiter mission. Since people called Mangalyaan, we accepted it, fine. These are the scientific missions we did for science studies. Let us look one by one. Chandrayaan-1 was launched in PSLV. This is a smaller satellite, PSLV was sufficient. It was launched in 2003. It was declared by Prime Minister in 2003. Chandrayaan takes off from Satish Dhawan Space Center in 2008. And it was shown in the video, it had a small probe at the front. It was dropped onto the moon. Just dropped, like you drop a stone onto the earth. And that is the first object which touched the moon made by India. And the interesting part is Chandrayaan-1 did some studies on the moon and it confirmed that there are water particles on the moon. And that too, its percentage is more in the South Pole. It is more in poles. Compared to North Pole, it is more in the South Pole. Till then, all space scientists were studying moon more or less at the belly point, that is the middle point. After Chandrayaan-1 observation, they started looking at South Pole. Now you see most of the landers are going to South Pole. That is one contribution of Indians to space industry. This is the moon impact probe which was mounted at the front tip of the Chandrayaan-1. And it has given a few photographs of moon through its camera. Next, Chandrayaan-2 and 3. Chandrayaan-2 and 3 is meant for softly landing. It is not dropping the stone. It is like we ourselves jumping. When we jump, we have to land softly, correct? So Chandrayaan-3 should softly land onto the moon. This is totally around 4,000 kg, 3,900 kg. It has two parts. Both parts together will be launched. It will go close to the moon. It starts moving around the moon. Then these two parts will get separated. This will keep moving around the moon, which we called lunar orbiter. It keeps moving around the moon. Whereas the top portion is the lander that landed on the moon. That is how the whole mission went on. So these are different photographs. This is the orbiter. This is the lander. This is in our laboratory. Now both have been assembled here and it is assembled onto the rocket. This is the top part of the rocket. After assembly, it will be kept on the rocket. That is how activities were done. And when we launched, first it was going around the earth. We will fire an engine. It keeps going away from the earth. further away. In the next orbit it will go further away. In the next orbit, when it comes, we will fire the engine. It will go further distance. When it was going here, moon also has come. Probably in the next orbit. This is another last earthbound orbit. And again the spacecraft will come back. When it comes here, we will fire the engine. When it moves, moon also will come. So when the spacecraft goes close to the moon will catch the spacecraft and the spacecraft will start moving around the moon. So that is how the moon capturing happened. And you see this is a composite, both parts are together. When it start moving around the moon, at one stage those two parts will get separated. So separated, finally lander will be made to land on the moon. That was the whole mission. It took around 1.5 months from launch to catching of the moon and landing on the moon. And these videos will explain how it happened, the landing. This is the rover which is kept inside the lander. This is solar panel of the rover. This is all animation. We have photographs taken from the lander and rover that also will be shown. These are actual visuals. Ramp got deployed. The rover is sitting here. Now the rover will start moving. The rover is moving on the surface of the moon and it is made to rotate here. This is the Shiva Shakti point where the lander landed. The rover traversed like this. It came here and it found a big crater on the moon. Then it decided, if I go forward I will get into the moon and I will not get the sunlight. So it went back, came this side, then came here, came here and it saw one more crater, again gone back and finally reached this point. It is an autonomous vehicle. Not like our car where the driver will decide which side to turn. Rover has cameras, rover has sensor, rover has its own computer. The photographs of the camera, details of the sensor will go to the computer. Computer will analyze and give instructions to rover whether to go forward or not to go forward. Many people will ask, sir, when rover was moving on the moon, as ISRO scientists, what you were doing? What you people were doing? Watching. We were also watching. Because rover does everything by itself. That is how we designed the lander and rover to land and move around. Moon will have sun for 14 days and no sun for 14 days. For us, day means when we have sun, we call it day. When there is no sun, we call it night. For 14 days of earth, moon will have day. For 14 days of earth, moon will have night. Our lander and rover will work only when there is sun. Therefore, they have worked for 14 days. In 14 days, rover has traversed 100 meters length on the moon, did lot of scientific studies, and it has sent the data to Indian scientists. This is the crater which our rover tried to, it went close to the crater, and it went back, decided not to enter into the crater. These photos are taken by the rover and sent to ground. This is one study made by Chandrayaan, the temperature on the moon. I don't know, the students from the back bench will be able to see this. At the surface, temperature of the moon is 50 degrees centigrade. Normally when we think of moon, we think it is very cool, correct? But the moon surface temperature is 50 degrees centigrade, quite hot. It measures the different materials available on the moon. It has measured aluminium, iron, sulfur, different chemicals available. That is, there was one equipment which will touch the surface of the moon and it will analyze. It will also send a laser light. Based on the laser light reflections, it will analyze. There were different equipments on the rover as well as on the lander to study what the soil of the moon is made up of. We have even measured the vibrations on the moon. We will have earthquake here. Whether moon also will have moonquake. To study that we had experiments. So these are the experiments that we made. Chandrayaan was not just to send and get appreciation from the world. It was also to get this type of scientific information about moon. This is Mars orbiter mission which went around the Mars. It has taken photographs of the Mars. This was one challenging mission where using the gravity of the earth we traveled in the space. Later using the gravity of sun we went up to Mars. Then using gravity of the Mars we captured the Mars and went around the Mars and studied the surface and environment around the Mars. This is the activities done by Mars orbiter mission. And right now our Aditya spacecraft meant to study the sun is working in the space. Aditya L1 is kept at 15 lakh kilometers away from the earth and it is studying the sun and the environment around that zone which is called as L1. And if you see, this is the sun, this is the earth. In between there is a point called L1. Especially for students I want to tell you, L1 is called as Lagrange point. Lagrange. Lagrange is a scientist who found that between sun and earth there are 5 points which are useful for scientific application. And he numbered it as L1, L2, L3, L4, L5. To study sun, L1 is the most preferred point because in this point the gravitation of sun and the gravitation of earth will be equal. So neither sun will pull you nor earth will pull you. You can stay there for a long time. So that point is called as L1. In Aditya L1, Aditya is the name of the sun. L1 is the place we are placed. That is Lagrange point. The recent experiment we did is SPEDEX, Space Docking Experiment. It's a very challenging activity. We made 2 spacecraft, launched in one rocket, and after going to the space, those two rockets will go and catch each other. It is like in Coco, one player will be running, other player will go from the back and touch him. Here it is not only touching, you have to catch the spacecraft. So that is called as a docking. See, like this, these two spacecrafts, they caught each other. It is not only catching, after firmly catching, there were two connectors on the spacecraft. We made electric power to be transferred from one spacecraft to another spacecraft. With this, we have proven the technology. Tomorrow, if you want to go and catch any spacecraft in the space, where the catching facility is available, you can send the second spacecraft from here, and this docking can be done. This type of facility is there in International Space Station. And if we have to go to the International Space Station, we also should have this technology. Why only International Space Station? We have a thinking of making our own space station, Bharat Antariksha Station. Even for that, this technology is required. Very recently, we have demonstrated this SpaceX-1 technology. Now we are going ahead with more complicated SpaceX-2 technology. And we are going forward with human space mission Gaganyaan, where we have a mandate, we have a decision to send human beings to the space in our own vehicle. Recently, one Indian astronaut went to International Space Station and he came back. Neither the module was Indian, nor the rocket was Indian, only astronaut was Indian. In future, wherein right now works are going on, we will make our own module, which is called Gaganyaan, where at the top portion is called crew module, where 3 astronauts can sit, and bottom module is service module. This will be launched in GSLV Mark 3, which we call LVM3, Launch Vehicle Mark 3, wherein it will go to the space. After a few orbits around the Earth, the whole module will come back safely. We will get back the astronauts. This activity right now going on. In a few years, you will see several launches related to Gaganyaan. After 3 to 4 experimental launches, once we get confidence that we will be able to send astronauts to the space and bring back safely, we will send our own astronauts to the space and bring back. In the next phase, there is also thinking of sending Indians to moon. These are the future missions. Chandrayaan-5, you will see a very big spacecraft. It is made up of 5 modules. It will be sent, module by module, it will be sent to the space. There they will catch each other. They will go to the moon. It will land on the moon, collect around 2 kilograms of moon sand and come back to the earth. That is the beauty. We have studied some samples of the moon with 1 or 2 experiments which we could send along with the lander. But if you bring sand itself here, we have a lot of laboratories, we can do much more experiments. Therefore, Chandrayaan-4 is being designed where it will go to the moon, collect the sample from the moon, safely bring back to India. With this, we can do experiments, studies on the soil of the moon. Another next project is Chandrayaan-5, which is also called as LUPEX. It is Lunar Polar Exploration. As I told, after Chandrayaan-1, people started looking at South Pole. Chandrayaan-2 also landed at the South Pole. But how far? You see, equator is 0 degree. Correct? Normally we consider equator as 0 degree. And pole as 90 degree. Chandrayaan-3 landed at 64 degrees south. It is not exactly the pole. Pole means what should be the number? 90 degree. But Chandrayaan-2 landed at 64 degree. Chandrayaan-4 is going to 84 degree, much closer to the moon, pole. Whereas Chandrayaan-5 will land at 89.5 degree. People will ask, why not 90, sir? 90, there is a crater. We cannot land in the crater. There will not be sunlight in the crater. Therefore, next to the crater is 89.5 degree. We are going to land at 89.5 degree. And there is a rover made by Japan. Chandrayaan 3 also carried a rover. That rover was 25 kg rover. Whereas Chandrayaan 5 will carry 400 kg rover. And advantage of going to South Pole, we told on the moon 14 days sun, 14 days no sun. But if you go to pole, 6 months sun, 6 months no sun. That is the advantage. But though sun is there, the sun intensity will be very less. So in that 6 months, first month the sun will be there but heat will be very less. And the last month also it will be setting down, there also heat will be very less. In between 4 months we will have very good sun. So that means around 100 plus days, more than 100 days, we will have sunlight. Chandrayaan-5 mission will work for more than 100 days exploring the moon. We want the sun for studying, but we want shadow to check where is water. On South Pole, there are small mountains and they have shadow on the moon. Some places the shadow is such that never the sunlight will fall there. Always shadow. Such zones are called as permanently shadowed region. शुरुआत से ही वहां sunlight ही नहीं आया है. And there is a thinking that we will have more water in that zone. This rover will go in search of such permanently shadowed regions and it will do experiments there. So that is the plan of Chandrayaan-5. After many such experiments, we are going to send man to moon, rather Indian to the moon. So these are the future programs of the satellite. As far as rockets are concerned, these two were there in the initial phase. Now SLV and PSLV are no more available. ASLV, PSLV is working. We have GSLV, we have Launch Vehicle Mark III, and one more small rocket called SSLV, which can be realized in a few days based on the requirement. So these are the series of rockets that we have developed by ISRO. This is another advanced technology, reusable satellite launch vehicle, where you send the rocket and after doing the work, bring back the rocket. Here there are a few models. On the right portion, a small rocket is there. At the front, you will see this type of construction. That is the model of reusable launch vehicle. We have conducted a few experiments on this. In future, we are going to have this type of rockets. And this is the only launch pad right now available in India. If you want to launch any rockets, near Chennai, Tamil Nadu, there is one island. Of course, it belongs to Andhra Pradesh politically. This is called Sriharikota. This is the aerial view. What you see here is the sea, and this is the whole land. I don't know how far you will be able to see. Of course, I will show closer views. This is one launch pad. This is another launch pad. There are two launch pads available in Sriharikota. The first launch pad, it looks like this. This is a big steel structure. Inside the steel structure, rocket will be assembled. Stage by stage, we will assemble the rocket. Inside the building only we have to do, we cannot assemble outside. Now the whole rocket assembly is completed. We have to launch. How to launch? Rocket is inside the building. Can we launch like that? When rocket is inside the building, now what to do? Any idea? Rocket is now inside the building. Now we have to launch the rocket. What should be done? Rocket should be brought out, right? रॉकेट को बाहर ले आना है. नहीं, इसमें टेक्नोलॉजी ऐसा है कि रॉकेट बाहर नहीं, बिल्डिंग ही नीचे जाता है. होल बिल्डिंग of 76.5 meter height will move on wheels and it will go back by 10 meters. That is the beauty of first launch vehicle, first launch pad. Here the rocket is ready for launching. Whereas the second launch pad is not like that. It is as you expected. This is the assembly bay. It is a concrete building. Inside the assembly bay, rocket will be launched, assembled. After assembly, this is a pedestal. On this pedestal, rocket will be moved by 1 kilometer to the launch pad and we can launch. This is the second launch pad that is there in Sriharikota. This is how inside of the assembly bay looks. These are the platforms. Wherever you want platform, there you can open the platform. Normally this will be closed. If you open the platform, here platform will be available. People can go around and work with the rocket. Here I don't know whether if you are able to see, one platform is closed because there is no need to open here. Wherever requirement is there, their platform can be, you can take it to any level, rise, lower, open, close, all that can be made. Any type of rocket can be assembled in this launch assembly bay. You see here all the floors have been closed now. Rocket is free to move. At the far distance, launch pad is there. Now you see rocket has come out of the building. Rocket is moving out. These are the platforms which was open there. Now it is closed. Rocket is on the pedestal. It is going towards the launch pad. And this is how the journey will happen. 1 kilometer journey from assembly bay to the launch pad. From there, launch will happen. With this, if you ask what is the track record of ISRO till now, we have made till now 132 spacecraft from Aryabhata to NISR, recently launched satellite. From Aryabhata to NISR, we have made 132 spacecraft. We have launched 102 rockets. If you have seen the live of NISR, our chairman made a mention. This is our 102nd launch from our land. We have launched till now 102 rockets. Many university students have made satellites. They are called student satellites. And some private industries also have made. Like that, 18 satellites ISRO has supported. Re-entry missions, 9 missions we have done till now. And till now, we have launched 433 satellites made by different countries. We saw in the beginning, our Aryabhata we were not having rocket, we went to Russia. INSAT we were not having rocket, we went to America. INSAT 2 series, we went to Europe. Now, other countries are coming to India to get their satellite launched. We have launched England satellites, we have launched American satellites. 34 countries till now have used this facility. They have got 34 countries have given their launch spacecraft to India to get launched in our rocket. Whenever I make this presentation, 1 or 2 days before, I will once check our ISRO website. Is there any progress in this? After NISR, one number will increase, right? But I am seeing for last 3-4 years, this 34 is not changing. What it shows is, other than India, there are only 34 countries who can make satellite. And all the countries who are capable of making the satellite have come to India to get their satellite launched by our rocket. That is our achievement. With this, if I list down the achievements that we have made in the space technology, starting from the journey of Aryabhatta, we are the independent nation to develop spacecraft and rockets by ourselves. And there is one technology called cryogenic technology, which is essential for GSLV rocket. We wanted to buy this technology from Russia. America became angry because they had technology. They thought India will buy from America. But normally if you want to buy anything from market, what you will do? You will check whether the item is good and whether the item is cheap. These two you will check, is it not? We want good quality and we want cheap. We studied cryogenic engines available in all countries, and we felt Russian technology is good and it is cheap also. We said we will buy Russian cryogenic engine. America became angry because you are buying from Russia, you are not buying from America. So they threatened India that we will not support you henceforth. They were giving some technology, some materials, components for making spacecraft rocket. They said, "Aaj se hum nahi denge." India said, "No problem. If somebody is giving some help, we will be using that help. If he stops, we will make our own," right? So India started making our own cryogenic engine. Now we have two types of cryogenic engines made by our own technology. Finally, what happened? NISR, which is American payload, got launched in Indian cryogenic engine. One day America said, "You are not supposed to have technology." Now America has launched its own payload in Indian cryogenic engine technology. There are 6 countries who have the technology and India is one among them. And there are 5 countries who have reached the moon and India is one among them. And there are 4 countries who have reached Mars and India is one among them. And India is the only nation to reach Mars in its first attempt. The remaining 3 countries could not succeed in their first attempt. Repeated attempts only they could succeed, and we are the only country, or I can say first country, to reach Mars in the first attempt. And we are the 4th nation to land on moon. After our landing, Japan has landed. There are 5 countries in the world who have landed onto the moon. We are the 4th country. Japan is 5th country. Unfortunately, they could not land safely, but they could land. And we are the first nation to land on south polar region of the moon. We have landed at 64 degree. In future, we are going to land at 84 degree. And later, Chandrayaan-5 is expected to land at 89.5 degree. So these are the achievements that we can claim in our 50+ years of space journey and going on. And today we have decorated space with so many satellites. And India has become self-reliant. We have our own technology. we are even able to help other countries. Every year, India ISRO conducts training to third world country people to learn how to make spacecraft. From Aryabhatta days, where we used to go to Russia and we used to go to America to learn, today we have reached the stage where we are able to teach the other countries. This is the journey from Aryabhatta to Gaganyaan and so on. In the opening remarks, Madam mentioned rightly that till now these many missions have been done. Tomorrow if we have to go to Jupiter, if we have to go to Saturn, who can do? You can do. Future is in your hands. If you take up science seriously and work in this direction, it is now in your hands to take the journey forward. With this, I thank you.
Thank you, sir, for a very detailed explanation of India's space journey. He has transported us from history to the future in one session. Okay, if any student has any doubts or any questions, I request the students to stand up and ask your questions. Sir is ready to answer your queries. Anyone? So the students we have here today is from the secondary level, class 9 and 10. So many of the things that has been explained may be beyond their understanding, but I'm sure there are students who are curious and want to ask more questions. Students, the time is given to you. Anyone? I think there is no question, sir. Oh, thank you so much, sir. We are so privileged to hear this lecture from you. And we wish you success in your future endeavors and your future projects, Chandrayaan-5. Students, let's give a round of applause for sir, please, once again. Our next session focuses on how space technology touches lives on the ground. May I now invite Dr. Jonali Goswami to deliver the talk on space applications for societal benefit.
Good afternoon, everyone. So it's really very challenging after that interesting lecture, and he made it so simple. I think now you must have some idea about the space technology, right? So here many questions. I don't know exactly how many questions may come in the quiz. So most probably you have heard attentively that lecture? Yes or no? Yes. Okay. So you will get at least 2-3 questions, I think, from that particular lecture. Okay. So this is anyway. So today my topic is Indian space technology for societal benefit. So can you please raise your hand who has till now use this space technology for your day-to-day activity? You have used or not? No? Okay, so who has used till means any Google Map, any mobile you must have having na, the smartphone you have? Huh? So have you used Google Map? So what is this? This is a satellite map. And then while tracking also you are using GPS technology. Okay, space technology comprise satellite data, GPS technology together. Okay, it's called space technology. So sir has shown, who is he? Vikram Sarabhai. He is father of Indian space program. Okay, we call him as a father of Indian space program. And he is born in 12 August 1919. And we celebrate this 12 August as National Remote Sensing Day. Okay? And Indian space program began in 1962. And he established Indian National Committee for Space Research in COSPAR. So in 1962 it started, and his dream to us that India should be second to none in the slide is not completely coming. It's a PDF or it will be difficult. Let's see. It's not coming full screen. Anyway, full screen is not coming. For advanced technology, he dreamed that India should be none other than other developed country to use this advanced technology for societal benefit. So, sir has already shown this is the birthplace of Indian space program. What is it? Name? Thumba. Thumba. This is equatorial geomagnetic earth magnetic field, and that is a very suitable place to study earth magnetic phenomena and upper atmosphere. Okay, that is why Vikram Sarabhai has selected it, as sir has already explained everything on that. And 1963 this place was established. And when ISRO was launched, anybody can tell? 1969. Okay, you have prepared for your quiz, right? So 1969 ISRO was established, and this is in 1963. So right from 1963, and then lastly when it soft landing and moon on which day? 23rd August 2023. So you can see the exponential rise in our space program. Okay. So till now sir has already given the statistics that we have launched 238 missions. This is 101 mission. Actually recently on 30th July we had another mission, that is NICER. Sir has already mentioned about the NASA ISRO synthetic aperture radar that NICER was launched. So it has become now 102. And this 132 mission, that is remote sensing, communication satellite and other satellite, navigation satellite, etc. And there are 5 this technology missions. Sir has already mentioned about re-entry launch vehicle. These are some experimental technology development mission, and 433 satellites from foreign we have launched from India, and 34 countries, sir has already mentioned 34 countries have participated. Just brief, because please remember this statistics also, it may come in your quiz. So communication satellite, till now we are having 18 satellites. Communication, you know, TV, which satellite we are using for our television? Do you have any idea? It's a series of satellites, right? So we have Earth observation satellite, around 24 satellites. Earth observation means when you are opening your Google map, you are getting some satellite data. It is observing the Earth. That is called Earth observing satellite. We have 24 Earth observation satellite like that. And then navigation. So you are using GPS. So GPS technology is not Indian, right? This is US based. So now we are having our own GPS system. We call this a NAVI. Okay, Navigational Indian Constellation. So NAVIC satellite we are having. So in recent, some of the phone, even iPhone 16 also, NAVIC is there. So means it gives more precise location because it is over India. GPS, it is for entire world. Okay, so NAVIC we are getting more precise location over India. And then space science, this 5 satellite, as sir has already mentioned, this Chandrayaan-2, Chandrayaan-3, all this Aditya, and then this ExpoSat, this also all are under, comes under. He mentioned as a special mission, this all is called as a space mission also. So space segment, as there are many satellites for this Earth observation, remote sensing. We call it as a remote sensing satellite. Why it is remote sensing? Because we are gathering information without touching the object. That is called remote sensing. We are gathering information from the space. Their camera is fitted there, and every hourly our Earth is mapping. Okay, so that is why it is called remote sensing satellite. So remote sensing satellite, we are number of, as I told, 24 satellite, Indian satellites we are having. Worldwide we are having many satellites. Remote sensing satellite has many categories. Some are black and white photos. Okay, some are colored photos. Which one will be better, colored or black and white for interpretation? Colored one. And black and white sometimes having more resolution. In your mobile phone, you know spatial resolution. You go by your mobile phone selection also, now what is the resolution of your camera. So similarly, in remote sensing satellite also, we are having different resolution. Okay, when resolution is, suppose if I call it the resolution is 1 meter resolution, it is a centimeter resolution, means we are getting more detailed information from those satellite camera system. Okay, so black and white, colored we call is a multispectral, black and white we call is a panchromatic, and suppose Tawang. So using normal camera from the space we cannot monitor Earth. Why? Because of cloud condition. Okay, so it cannot penetrate the cloud. The rays cannot penetrate because it will become entire white only from space when we see that already full of cloud. So in that condition, synthetic aperture radar, okay, that is in a microwave. I will not go in details because these are very technical. So just you know that technology is available that camera will penetrate, the ray will penetrate through cloud, and during cloud condition also we can have a clear picture of the Earth. This recently that NISR, it has that synthetic aperture radar, so that in cloudy condition also we can get a continuous picture, because we need in disaster, right? So disaster will not get in cloud-free condition. So in that condition we need data during our monsoon season or cloudy condition. So this synthetic aperture radar microwave data will be very useful for this disaster management. So we have Cartosat, as I told, this is up to 28 centimeter, up to 30 centimeter data we are getting as a black and white. Okay, so these are mainly used in defense, and then some and other cartographic analysis we are using this Cartosat data. We have OceanSat data for this ocean. Now you know this cyclone also. I'll show you how accurately we can predict the cyclone only because of our satellite data. So INSAT 3DR, this mainly is for climatic studies. So this we can get temperature data, relative humidity data, rainfall data using this INSAT 3DR data. So this slide is not coming. Actually, ISRO has taken one policy in 2023 that whatever data up to 5-meter resolution will make it free for the public. So the public can utilize this data for the societal benefit. Okay, so we have one portal for teachers or other faculties or other members also. I just want to inform that Unity is one of the portal from ISRO. There freely you can download data for your use. So that is up to 5-meter. If you need finer data than 5-meter, we are having that for government organization it's free, but for private organization some price is there. So that is cartosat, as I told you, 30-meter resolution it is available, 30 centimeter, sorry. So that finer resolution data, government employee for government organization it's free, but for private some price is there, but within 24 hours you will get the data. Just like Amazon, that nowadays this online portal, you have to just order, but some verification, some authentication you have to give, authorization you have to give that you are using this data for your research purpose or some other purpose. Okay. So as this one I told you many things that satellite data, what can be done. This is for natural resource and environment monitoring. So natural resource means now we know what is the geographical area of entire India. Can anybody tell? Yes, right. What is the geographical area of Northeast? 2.62. So, is it possible using this satellite data directly to demarcate our boundary and get the area? Right? So, now it has become very easy to go for inventory of our natural resource. You know what is the forest area? Out of 2.6 to 1.73 is forest area in Northeast. Okay, so it means readily we can give the statistics using this remote sensing data, and some specific software are also there. We call it the GIS software. For image analysis we have some imaging software. So immediately, suppose today, if somebody asks, can you give me the status of entire Northeast? Yes. Evening, by next day we can give the statistics. But that will be a very broad category. If we need at the district level, we have to choose some other satellite. If we need at the village level, we have to select finer resolution. Okay? Getting or not? Okay. So next is our food security and agriculture. Agriculture also, I will come in details. In many areas we are using this satellite technology. Developmental planning, in urban planning, I will give some example, different governance application, we are using this satellite technology. Disaster management, as I told, flood monitoring, flood inundation mapping, in everywhere we are using this satellite technology. Health and education also, you will be surprised to know in health, in education, this telemedicine, tele-education, this is a communication satellite, but through that, we are in non-connected area, we can go for this telemedicine, tele-education for health and education sector. So in this agriculture, as I told, this in all over India, this for area and production, for 8 major crops. Now area and production estimates we are giving, this government is giving using remote sensing technique only. Okay, so because otherwise what happens when we are getting some statistics that some concerned person will go to that area and he will do the eye estimate, right? So you will see that, okay, this much area. But when we take the data from the satellite data, exactly we can demarcate the area and then statistics we can get. So which one will be more precise? Using satellite data. Is not it? Okay. So next is our forestry. Forest, as I told, suppose some forest area is deciduous or evergreen, means all this type of forest, what type of forest is available. We can, sitting at one place only, we can see the area, that what type of forest is. Obviously, we cannot directly with 99-100% accurately, we cannot tell using the remote sensing data. For that, we need our field data also, but we can reduce our field ground truth verification using the satellite data. So, as you told, in drinking water, so all India level, even drinking water prospect zone also, we have mapped using satellite data. Watershed development, you can see, we can demarcate nicely the watershed of a particular area, which way the stream is coming, what is the first stream, second stream, like it means using satellite data, it's just a clear picture. You can demarcate the drainage, how this water is flowing, from which direction it is flowing, and then how much discharge also. I'll show you a few examples on that. And as I told, NR sensors, this is periodic inventory we are doing, and continuously every year we are doing at a regional level, and every 5 years we are doing at a district level this natural resource census. So application, see, right from acreage, as I told you, acreage estimation, soil resource mapping also. Soil resource mapping also, as I told, some derived parameter, not directly, we cannot go for soil resource mapping using the satellite data because it is covered with forest, it's covered with some problem. Soil is not exposed in some area, okay? But we can derive from some information from out of there. So this is a derived information. Damage assessment, crop damage assessment we can do. Agricultural drought assessment, this is one of the national mission. They are using this drought assessment using the satellite data. And then even you will be surprised in sericulture. Sericulture development also we are using this satellite data. How? We are not identifying the worm. What we are doing? We are identifying the area suitable for expansion. So we are getting some, suppose culturable, some wasteland, and then we have the soil data, we have climatic data. So those information we can integrate in software, and then we can get the area suitable for expansion. That is how we are helping the sericulture department where to expand. We are helping the agriculture department where to expand the most valued crop. For horticulture, we are doing for the horticulture department in different schemes, Government of India schemes. We are identifying suitable areas for expansion of different. In Arunachal Pradesh also we have done for kiwi, apple, I think many crop we have done for area expansion in different location in Arunachal Pradesh. So this is the acreage estimation. Now you can see one special layer you can get it that where how much rice area is there in Meghalaya. Similarly for Arunachal Pradesh also we have last 3 years we have done for this area estimation for the state of Arunachal Pradesh. So these slides are not coming properly, but you see using satellite data, even I am sitting in Shillong. But I can see that in Arunachal Pradesh, this particular district transplanting is going on. Okay, using technology, using continuously monitoring at 7 days interval, if you monitor, then we can see that okay, transplanting is going on, and this is the stage, this is vegetative stage, this is the pedicle initiation stage. Like that stages also we can monitor using if we monitor it continuously over a particular area. So like that, damage also, suppose particular crop is at particular stage, flood has come and crop was damaged. This the damage assessment also we can do using the satellite data. So here you can see this is a very good example. You know the Brahmaputra river. So changing its means always used to change the bank line. So you can see here this is the 2015. This pink color is the boundary for 2015 and this 2020. You can see 2020 how much area is eroded. So entire Brahmaputra stress we have estimated how much erosion has been taken place, how much agricultural land is eroded. You will be surprised that we have seen from 1970 some villages is disappeared because of this erosion. So those area estimates continuously last from 70 or 78 onwards. We are doing it continuously that how much area eroded by the Brahmaputra river. So this you can see that some animation that over the years how it is changing. So over the years we can see that, and then we can find out, suppose one particular land it's deposited, and for how many days, how many years it is stable. So we found around 50 island, it's more than 500 hectare, it's stable for 30 years. This data we have submitted to the government of Assam, and now they are using this island for productive agriculture. Not only for productive, even Oil India Limited, they have taken this database, they want to establish an infrastructure there. Okay. So this type of study we can do using the satellite data. So this stable size-wise, as I told you that I already, this one 500, more than 500 hectare, 200 to 500, different categories we can make, and then stability, 30 years stable, 20 years stable, 10 years stable, and then 10, if it is 10 years stable, at least some crop farmers can grow there, and then even whether it's a flood prone, whether it's a flood is not there, that study also we have done, and then how many settlements are there, which island already settlements are there. So that information also we can get from this satellite data. So this, see, you can see this January 2016, crop is not there, and then January 2018, that area. This area you can see 2018, and then crop is there. So temporal analysis also we can do using the satellite data. So forestry, this was up to agriculture. So forestry inventory we can do. The what type of forest, as I told you already, deciduous forest, evergreen forest, open forest, closed forest. So it's a scrub land or wasteland. Those classification also we can do using the satellite data. Even forest fire also, it's a very big mission actually. We are even National Remote Sensing Center, Hyderabad, and then NISEC, we are doing this forest fire alert system also using the satellite technology. See here, this is the example, this Baliparanda forest, this is in 1975, and if you see in 2019, this is completely deforested. So this is possible only using this type of temporal data. So here also you see is it closed in the month of Jan, this is in the month of November, and in the month of March, and this is in the month of November. Why it is green color? Because this is deciduous. Okay, and here it is coming as a completely full of, and you can see why it is red, you know. We in software, we can make the data in different color combinations. The red color we call it is a false color composite, because red we can interpret more. The interpretation power is more, and then our area full of forest. So if we make this forest area, vegetated area as a red, so we can interpret more accurately. So for water resource also, as I told that flood, this one early warning system we are developing for entire Brahmaputra, even for Subansiri, for that Nimco, you know, in Arunachal Pradesh also we are doing for this flood early warning system. So this is one of the application where we are doing, even means how much ditches is going to be from a particular stream, that water set also we can estimate using this remote sensing technique. See here, this is of 2019 September, or this is August, and this is the flooded area. So exactly how much area is inundated we can estimate using this type of satellite data. So if we see that if any settlement or any cropland is there, we can estimate accurately that this much area has been damaged or it is washed away because of the flood. So here also, if we monitor continuously for how many days flood extent, duration and depth, we can measure using the satellite. This satellite data is, as I told you, this is a synthetic aperture microwave data, because during flood, that entire our northeast region will be covered with cloud. So this is microwave data, so that we can estimate the inundated portion. See here in software we have that facility also, we can make 3D. Then we can visualize, we can do some simulation study. So how this water will come and how much teachers we can estimate also the teachers, total teachers. So similarly, entire Northeast region, this groundwater prospect map, this is 1:50,000 scale, no doubt, because here many ground data also integrated, because even well data also collected and then integrated. But at least 50 to 60% data was utilized from the space technology, means satellite data. This is infrastructure connectivity. So we have the entire database for Northeast region, where is the school, where is the public health center, and where is the another, suppose, connectivity, road connectivity. So this, you know, in Gati Shakti portal is there. So there also we have another portal. There you can analyze the gap. So at the how means what is the gap of two schools? Is it a 5 kilometer? Is it a 10 kilometer? That gap analysis for school, for health center, for other road connectivity, those analysis can be done using the GIS technology. So road alignment also. Road alignment, suppose we want to construct the alternate route. So using satellite data, at least we can see the slope. We can see the aspect. How to, means what are the criteria, means if we get the different criteria using satellite technology, we can use those criteria to find out the alternate route. So that is why in Arunachal Pradesh also this upper Siam to Sembosti and lower Dibang Valley, this two alternate route was, that plan was given using the satellite technology. And many work actually this Arunachal Pradesh Space Application Center they are doing for the state of Arunachal. So suitable urban development, you know this because we have, suppose we want to urban sprawl, it means it's not in a proper planning mode. So using satellite data, using space technology, we can give the potential area, we can give the suitable area for expansion. So this work, this is done for the Shillong city, and then government of urban development, they have accepted this for the master plan of Shillong city generated using space technology. So this is the Kibito, this is in Arunachal Pradesh only, okay. This is a model village. Actually, this came from the government that we need to develop this model village for the Arunachal Pradesh, and then okay. Anyway, can you please change the slide? Pradesh, can you please change the slide? Okay, this model village, as I told, just go to the previous. So this is the model village in Kibito, and then this using the satellite technology, we have 3D view of that area particularly. First we have seen, and then slope and what are the land use available, where is the settlement available. So based on that, a model has been developed and submitted to the government. So this restoration of coal mining, you know, in Meghalaya, coal mining is very extensively they are doing, and then we have mapped entire area, that red hole zone, there's a red hole area, and then those area is actually this, they used to go for deforestation, and then what afforestation procedure, and then we make some plan for afforestation also. So that way we are doing this coal mining area management. So next is ocean and atmosphere. So in ocean and atmosphere also, that you have seen in nowadays in news, every time we used to see our weather forecast, right? So weather forecast is using many satellite data, how this wind, how this cloud is moving, and how much area when to precipitate. This all information we are getting from the satellite data. And not only that weather data, even in coastal area, you may be surprised, coastal area we are giving advisory to the fishermen. Okay, so fishermen, even we are giving the potential zone identified for the fishing. And then when they go for this fishing, this alert also they get using the satellite data that cyclone is coming, this heavy rain will come, and this is the area for fishing. So this type of information we are providing through space technology for fishermen. So for disaster management, as I told you, in flood, we are giving flood early warning system. In landslide, we can monitor landslide area. Okay? So after landslide, can you monitor or not? Landslide area. Because you will get the clear picture of slide. Okay? So landslide inventory also we are doing. Even up to earthquake precursor study. Not exactly, we are not doing the earthquake prediction because this is our limitation. But space technology cannot do everything, okay? But it acts as a tool for various study. So for earthquake also precursor study we are doing, landslide inventory we are doing, flood early warning system, even lightning. Lightning, you know, many people, it is a major disaster. We don't know actually, maximum people dies from lightning. So using the satellite technology, NSEC has developed early warning system for lightning. At least in 3 to 4 hours in advance, you will get that lightning is going to happen. Because this is very important, those who are walking in the field, in the farmer's field. Okay? So these are the some of the example where this satellite technology is being utilized for the disaster management. So this cyclone tracking. So now you know in news also, because of our space technology, because of ours, that at least in few hours advance, we will get to know that in days in advance, we'll get to know that, okay, cyclone is going to come in that area. It's going to affect this area. So before cyclone comes, evacuation starts. That is how at least we are saving people. Okay, maybe we cannot save that infrastructure, but at least life we can save using this type of technology. And this is a great example of space technology for the cyclone particularly. And as I mentioned, whatever work we are doing at NSEC, we are not keeping with us, because this data we want to be utilized by the society, to be utilized by the user department. You will be surprised that each state, around 25 departments are using space technology. From each state, we have this was actually action from the Honorable Home Minister, that he has given us, that we just find out the user department who is using the space technology. And around 25 user department, 25 to 30, it's depending on the states, especially this one, we have seen that they are using space technology in different, even for Arunachal Pradesh, I have done a study for fishery development. You will be surprised, using space technology. We have done for 4 districts in fishery development. So even water quality study also we can do using satellite technology. Okay, those data we have done, and however, we have collected the water sample and then correlation we have done, and then we could see at least 80 to 90% accurate using the satellite technology, that water quality analysis. So whatever data we are doing, whatever project we are doing at NSEC, we are keeping it one platform. We call it as a Northeast Spatial Data Repository. So there you can see the data availability for Tawang also. And then just like that, if you want to download the data, you have to give the order, and within 24 hours, you will get to download the link, and as well as the directly in your mail it will come, data will come to you. Next. So this is another portal we call this a NER Disaster Risk Reduction, Northeast Regional Disaster Risk Reduction. So whatever under NER, whatever disaster related work we are doing, and then we are pulling data from different sources also. Suppose one earthquake comes, you will get the update in our NER portal, what is the magnitude of earthquake, where it, and then what is the distance from the that map also. Even for lightning also you will get the warning, and then some advisory also it is available in our NERDRR portal. So Bunidhi, as I told, is based on the ISRO's policy 2023. This is the last one. This Bunidhi portal, these satellite data are available for free of cost, up to 5-meter resolution. Okay, so please visit this website. As I told you, please visit this Bunidhi website. Those who are interested, at least you see our Indian satellite as well as some foreign satellite archives data are also archived there, and you can see that what type of different data are available there in Bunidhi portal. Okay. So thank you so much. I think I have covered whatever we are doing, and so this is the building of our office. So I request all to come, and then I just want to know anyone is there who has participated in any Sparks program, because 3 students from I think this is only 9-10 students, right? Okay, from 11 standard students, 3 students has already participated in our Sparks program. There actually I told in the beginning only that 100 students from Arunachal Pradesh will be visiting this ISRO headquarters, different facilities of ISRO headquarters in Bangalore. Okay, Yuvika, anyone is there? See, this Yuvika program, Yuva Vigani कार्यक्रम, this advertisement used to come in the month of January, okay? Because January or February, those who are studying in class 9 category mostly, suppose in 2026, that advertisement will come. Those who are studying in class 9 in 2026, January 1st, they are eligible and fully sponsored. That is the thing, that you will get the entire travel there, 15 days you can stay there, and then you will get lots of material, you will get lots of activity, you will get to do lots of activities there. So please visit ISRO website as well as these websites, whatever I have mentioned, please do visit those websites. Okay? Thank you. Any questions or anything you can ask, please? Anything you can ask, no problem. Because I know you are 9 standard students. Any curiosity or anything that I want to study this, and then whether it's possible to use this satellite technology or not? Any example or any challenges? Yeah.
When tourists visit to Tawang, when they visit to track out location of places, even if we share our location, they are unable to locate the places. Why? What would be the reason? Exact location.
Location for the tourist.
Yeah, tourist. If we, for example, if they visit or want to visit the place, and we share a location, instead of sharing our location, they are unable to trace out that location. They face lots of difficulties.
So location, how you used to share the location using your any RFID mode technique?
Yeah, through WhatsApp we have.
WhatsApp.
Location sharing.
Okay, because of network, I think, and this phone, this one mobile phone network, I think, you are not able to locate. Because now, if you go for some other kind of, because the location accuracy they are not getting. Even here now we are getting this mobile network. It's very less. But if you go for different, now GISAT 11, sir has mentioned, in some area where connection is not there, we are having this satellite-based live location-based information. Satellite-based, some antenna will be required, and that you can contact ISRO, and those
if places is not connected with any mobile network, we can give that antenna, you can give that network from the space. So because of, I think that WhatsApp you are sharing the location, right? So because of mobile network you are not able to track them. That is the main reason. And then you have to shift from mobile to space technology. That already it is, that technology is also there.
Thank you.
Good afternoon, ma'am.
Yeah.
Actually, you are well aware that we are living at a very high terrain and sharing international borders with Tibet and many countries. So, actually, we are facing a lot of internet connectivity issues here. While many advanced countries like Japan, China, they have developed 6G, 7G, but Taiwan, particularly in the headquarter area, we are getting 5G. That too, the speed is very slow, and when we get out of the headquarter region, we are still dependent on 3G or 4G networks. So when can we expect some superior network? And is ISRO working on these directions?
Yeah, actually, yeah, that GISAT-11 that is specifically for Northeast region. But whatever problem you are facing, mainly because of the mobile network. Suppose for Jio, for BSNL, they are taking some bandwidth. Okay, so maybe they are not putting in Arunachal Pradesh. This is not from ISRO. ISRO is only the transferring the data. Okay, so it is depend on the mobile network provider. But if you if you approach ISRO regarding that GISAT-11 or you want some separate connectivity here in Arunachal Pradesh, in Tawang, maybe ISRO will work out in that way. But ISRO as such, we are not giving any mobile network provider because we are giving the particular, what we call is a band, particular band for a particular mobile network provider. Okay, particular frequency to a particular mobile network provider, and it is their duty actually to give a tower. If they put a tower, because in our area where we sit, you will be surprised, even we are facing the same problem in Barapani. Okay, even if we are ISRO, we are facing the same problem. But we told this one BSNL, and after that they have installed one tower in our this one. So BSNL network now we are getting it fully. So that is the solution actually. Even if we are from ISRO, you will not get network there. Okay? Thank you. Anything from student side? Yeah.
Good afternoon.
Yeah, good afternoon.
Ma'am, I'm interested in Space Academy. How to join Space Academy?
Or Space Academy. Okay. So after class 12, just like IIT you will have G Advanced, right? So IIST, Indian Institute of Space Technology, one institute is there. You can apply that separately. They used to conduct that test. It's almost equivalent to IIT, and there you can go for BTech in space technology. Okay, and if your result is very good, your job is assured. Okay, so you will be this one in NSA. We have directly get appointment as a scientist from IIST at different institute of ISRO. This IIST exam you can crack and then you can become the space scientist.
Thank you, ma'am.
किसी को हिंदी में भी पूछना है तो पूछो, मे बी आई ट्राई, हो पाएगा.
कुछ पूछना है? Okay, otherwise time is over. Okay. So that quiz competition will be at 2 o'clock. So now I think. Thank you so much.
Thank you, ma'am, for the wonderful insight. Students, we have learned through ma'am's lecture that space technology is not just about planets and rockets, it is about its being used in daily lives and how it is going to improve our lives. So keeping that in mind, we will now break for lunch. So lunch will be served and we will gather back to the hall exactly at 2 o'clock, 2 p.m. Our chief guest, DC Madam, is going to be with us during the quiz competition as well as the prize distribution. She has specifically wanted to attend this quiz competition to be with you all. So I request all of you to be on time and gather here at 2 p.m. sharp. Thank you.